So our next presentation is by Federico. Federico, are you there?
Yes, I'm here. Hi,
Hey,
everybody.
hello. People probably know Federico. He is one of the. It's funny. In your last Thursday. So Federico runs these language engineering meetings every Thursday evening, and some of you probably are here because of that other meeting. And in the last meeting, Federico gave a talk, and I introduced him. So I'm going to do that again. So this is Federico.
Perfect.
He he runs Strumenta, an Italian language engineering community company. He also runs the community around it. And again, yes, is there anyone who doesn't know Federico? Yes, maybe there are. So today he's going to talk about making MPS part of an ecosystem, getting stuff in, getting stuff out. Again, it emphasizes this thing that I also mentioned in Tom's talk, that I like how he used Yeoman to kind of bootstrap a project, and emphasizing that there's more to a project than just language. And you're kind of going in the same direction, Federico.
Yes, yes.
All right, then take it away.
Okay. Well, thank you. Thank you to JetBrains and Itemis for organizing that. And it's quite an honor to be introduced by Marcus. It's going to be difficult to follow the previous presentation because this was really great. Mine is going to be a bit different because I'm not going to show you code running into MPS, but I'm going to talk about some of the potential usage that you can do of MPS, and hopefully this will give you some idea to get more value out of MPS. Now, for the last few months, I've been reflecting around this idea that most of the organization we work with have at their center something that they use to produce value that affect their processes, it affects the internal communication, it affects the R&D efforts, it affects training. And that is, of course, knowledge. So for many of the organizations we work with, knowledge is the main way that they use to produce value. So because this has to be taken in account in the process they develop to create knowledge in the best way possible and to take to produce value out of the knowledge they build. Communication is mostly about communicating the internal knowledge that is built. R&D development means often creating new knowledge, but also putting knowledge to use. And in my opinion, this is where I've seen many organizations running into issue because it takes too much time to transform the knowledge they have into a product that is valuable. And finally, training is also about spreading this knowledge to all the new people that join the organization during the life of the organization. Okay, this is a bit abstract, of course. So let's try to understand why this is related to MPS. Well, I think this is related to MPS because basically we use MPS to capture knowledge and store it into MPS models. Then when this knowledge is captured into models, we refine over it, we improve it, it evolves over time. But this knowledge remains trapped into MPS, and I think this is limiting. Given we have this incredibly valuable asset trapped into MPS, we could think about better ways to get value out of it. So I think that MPS interoperability, so making tools communicate with MPS or the external world communicate to with MPS to produce more value, can be divided in 4 different aspects. The first one is bringing existing knowledge into MPS. Let's say that your client provide you a diagram in visual paradigm or some requirements in Excel files, you want to bring them into MPS to combine them with the knowledge you are going to build in MPS. Or you may want to generate stuff out of MPS. For example, you describe a great therapy in MPS. You then want to generate maybe a mobile application that the user can use to follow this therapy. Integrating of external tools in MPS means finding tools that can be used to enhance what MPS is capable of. For example, we have seen in the previous presentation that there was an integration of GraphViz to generate diagrams inside MPS. I will talk a little bit about this too. And finally, there is a fourth aspect that I think is more recent, and this is about making external tools communicate with MPS. For example, opening a web editor that talks with MPS and show you in a browser some of the information that is available in MPS. Okay, these are the four things I would like to discuss. Now, let's start with the first one, bringing existing knowledge into MPS. In general, you could do this in two very different scenarios. The first scenario is the one in which your organization has finally saw the light. They understood that MPS is where they want to build all existing knowledge. Unfortunately, the organization is not born today, so before they've built all sorts of knowledge in other tools like Visual Paradigm, Excel, some other modeling tools, doesn't matter. We want to run one single time an importer, bring this knowledge into MPS and forget about what was existing before, throwing away existing files and editors. This is one case. Another case is the one in which we instead cannot forget about those external editors. And that could be the case because maybe for certain specific kind of knowledge, we have great external editors. Maybe our people really love to use Visual Paradigm to describe processes, and they want to keep using that for that specific piece of knowledge. Or another case is the case in which we are working with other organizations and other departments, and we cannot convince them to adopt MPS, so they're going to send us, I don't know, Excel files, and we have to deal with that. And every time we receive one, we have to use it inside MPS. So why you may want to bring all your knowledge into one place, and that place will be MPS? Well, the main reason I see is that because you want to verify that you have overall consistency. For example, if your clients provide you some requirements or test case as an Excel file, and you build a solution inside MPS, it's very convenient if you can import what your client have provided and verify that it is consistent with the solution you have defined. So this is one case. The other case, the case in which you want to abandon existing editors and replace them with editors you build in MPS, is because this editor that you build in MPS can, well, you are in control of them, so you can evolve them, you can add more and better consistency checks, and as your processes change, as you things you need to represent change, you can evolve these editors so that they fit perfectly your use case. So I think this is a good reason to bring stuff into MPS. Now, there are also cases in which you don't want just to read stuff that is created outside of MPS and just read it, but you want also to maybe change it a little bit while within MPS. You can do that, and you can do that with two different strategies. One is using one feature of MPS that I think not many are familiar with, that is the custom persistence. Probably you know that MPS store the models by default in these XML formats. You can also write plugins to MPS so that it becomes able to read and write models in another formats that you decide. For example, JSON, or for example, if you want to represent Python code, you may create custom persistence so that models are saved as Python files. This is one strategy. Another strategy that I've seen recently used in Modelis, this amazing project from Sasha Lisson that we'll talk about it tomorrow, is the synchronization approach. Basically, you create your own models in MPS, and then you run a listener that observe any change you do in these models that initially is the same information as some external data source, and every time you do a change, you replicate the change in this external source. For example, let's say that you want to evolve some information that is stored in a database. You can initially create a copy, a model that has the same information as the database, and when you change something in MPS, you insert a record or modify a record accordingly in the database. So this is the synchronization approach, and I think it's very interesting. Now, another topic to consider is the kind of formats that you may want to import in MPX. Typically, I see these three cases. You are looking to some interchange format, XML, JSON, or Excel. You may not agree that Excel is an interchange format or it shouldn't be, but in practice it's used in this way. Then you frequently have some kind of textual formats, and sometimes you have binary formats. Now, if you're dealing with these three formats, XML, JSON, or Excel, there are simply a lot of Java library that you can use in MPS using the base language, which is Java. So it's very easy to import these three formats. You should also consider that for XML and JSON, there are MPS language that could facilitate this task, because basically you can read these files using custom persistent and directly open them in MPX. So that's very easy. Another very common case is the case in which you need to parse some kind of textual format. Now, as Marcus said before, I work at Strumenta, we do language engineering, we do some project with MPS, we do some other project without MPS. In those other projects, we always use Antler. And there is no parsing parsing problem that I was not able to solve, or we were not able to solve using Antler. So I'm not saying that Antler is always the best solution, but I'm saying that if you learn to parse stuff with Antler, well, basically there is no problem you cannot solve. No parsing problem you cannot solve with Antler. But I think you should be aware of these two repositories and these two projects. The first one is InMemAntler. Now, for people that are not familiar with Antler, Antler is a parser generator. It basically means that you define the grammar of your language, then you invoke the Antler tool to read the grammar and generate some source file in some target language. It supports many, but for example, Java. So it create a Java file. Then you need to compile that file. You need to add that class file obtained by compiling the file into your library, into your project. You need to instantiate the class. At this point, you can run your parser and run it with some input and obtaining a parse tree. This is a complicated build chain. You can instead use InMemAntler and basically do all of this in memory. So run in the grammar, generate the Java source file in memory, compile it in memory, instantiate it immediately and use it. That's much easier. And another repository that you should be aware of is Grammars Before, which contains simply hundreds of grammars. So it's very possible that if you want to parse some common format, there is already a grammar that you can use. And so by combining these two projects with the capabilities of Antler, you can import relatively easily in MPS any kind of textual thing. In the case of binary formats, there is this old project of mine that is not extremely mature, but I've used it to import JVM bytecode and PNG files and basically extract the information I needed. It's a DSL to describe binary formats. and it's relatively easy to use, so maybe could be of interest to you. Okay, this was the first aspect of interoperability, so reading stuff and bringing into MPS. Then we have the opposite, so taking stuff out of MPS. And this is typically the case because, in a way, in MPS, you bring your knowledge or build it, and then you want to produce something valuable that can be used in the outside world. So one way of doing that is generating code that you can compile, and you have some executable that you can give to someone so that they can use it. Or similarly, you can generate some XML and JSON code, and then you have an interpreter running outside of MPS that execute this code. This is basically the same thing. You can also generate PDFs or diagrams so that human can read them outside of MPS, or you can generate some sort of inputs for some software outside of MPS. For example, you can generate an AutoCAD file, or an Excel file, and someone else can use them outside MPS. Now, one thing to consider, one possible problem that some adopter of MPS see is the locking problem. Say, yeah, but what if I put all my valuable knowledge into MPS and one day I don't want to use MPS anymore, I'm locked into MPS? Well, this is not the case, because we are going to see that there are basically a million ways to generate stuff out of MPS. So to extract your valuable knowledge from MPS and continue your life without MPS if you choose to. Okay, that said, when we talk about generation, I focus on three different aspects. The first one is how do we trigger the generation? The second one is how do we deal with intermediate transformation? And the third one is how do we serialize the information? So basically, how we save it on file. Now, when we talk about triggering the generation, it seems to me that many users of MPS are familiar with only the first way of trigger the generation, so the standard way. You build your text generator, and basically every time you make your project, you build your module, this is triggered automatically, and some file is produced on disk. Okay, this is one way, but there are situations in which you may want to use other approaches. For example, in some projects we use the manual approach. So we create a new action that we add in some menu, or we add a button in the editor, and the user can click on it manually to trigger the generation. Why this is useful? This is useful when your generation is expensive. If your generation takes 3 seconds, it's okay to have it run it all the time. If it takes 3 minutes or 15 minutes, because maybe combine some external information or it's very complex, you don't want that to happen all the time because you mindlessly click on the make button. Also, if you're building complex generation system and you have side effects execute as part of your generation. For example, every time you generate something, you want that to be pushed to some external repository and a tag to be added. You don't want that to happen all the time that you just build the project. So you may want to have control, and this is why it makes sense to have the manual approach. And finally, sometimes it's useful to trigger the generation from MPS running headless, so from the command line, as a way to say, for example, as part of some continuous integration process. So this is another possibility to consider. Now, this third one, I think it's underutilized because it requires creating a build configuration. And this is one of the biggest pain points in MPS. Now, one thing that I want to discuss is the problem with transformation. And this is a problem I see every time someone that not very familiar with language engineering, try to write a transpiler, either in MPS or outside MPS. And the problem I see is this, that a lot of language engineers that are maybe not so expert tend to just think, okay, I have to transform this input to this output, I will just write a transformation. And if this input and output are very different, it will be a complex transformation. Suppose that you are trying to to translate Haskell into Java, if this is even possible. The languages are different, so the transformation will be complicated, and the result is that the resulting transformation will be unmaintainable. In those cases, it makes a lot of sense to create an intermediate model, one or more, so that you can translate your initial input into the intermediate model and then your intermediate model into your final output. Now, this is even more important if your input is written in some DSL you created, because probably you're going to evolve this DSL. So the DSL will change over time, and if you have one big transformation you have to change all the time, it's going to be even more painful. While if you have an intermediate model and two simple transformation combined, what could happen is that many times, not always, you can be able to absorb a change in the DSL within the first transformation, obtaining an intermediate model that uses the same concept that you had before, and therefore you don't need to change the second step, the second transformation. And this is also valid for changes coming from the other direction. Suppose that initially you are generating some Angular application, later you decide that you want to generate some React application. So you may want to, in this case, hopefully you will just need to change the second transformation and maybe just a tiny bit of the first one. While if you have a single giant transformation that is a mess, well, it would be extremely painful. So in general, you want to split complex transformation using intermediate model, because it means having less complex transformation that are testable in isolation, and in many cases you are able to absorb changes on the input or the output. Now, there is also very good documentation about the standard model transformation, so in the generator cookbook, so you can read it. But there are also alternatives to using the standard model transformation. Now, these are alternatives that I think are very interesting, but I've not used extensively in projects, so I cannot speak intelligently about that, admitting that I can speak intelligently about other stuff. But you may want to look into the shadow models from Sasha Lisson, that has basically built half of the cool stuff out there, and declare. These two frameworks permit to create incremental model transformation. So I think they deserve that you take a look at them. Now, once you have processed the information, you have a final model that is basically contain the exact representation that you want to save on disk. Well, you have the last step, that is saving that stuff on disk. Now, sometimes you want to save that stuff as XML, JSON, or Excel, and you can use the libraries, the common libraries that we have, like JSON, the one from Google, or tons of other libraries. If you need to generate binary formats, in my experience, this is much simpler than reading binary formats. So typically, I just use a byte array output stream and deal with that. And then there are cases in which you need to save textual stuff. In this case, you have two alternatives. If you are lucky, you want to target some language for which there is already a generator, because that language is already supported in MPS. That is the case for Java, well, it's called base language, but it's Java. For C, the embedded project, there is JavaScript, the project from Marco Lombardo, if I'm right. There is R, that I think supported for Fabien Campagne, and there is XML. I'm not sure who wrote that one, and there are C#, C++ that may or not be open source, I'm not sure. But there is this growing amount of languages for which there is already a generator available. So if you transform your input into the models of these languages, you can then use the standard test generator that comes with these languages, and so you don't have to write your own. So consider that. If you are not lucky, you will need to write your own test generator, and there are different ways to do that. Now, I'm not saying this is something I would advise, but I personally like to write some code using the base language and string builder. I'm a simple guy, it works very well for me in many cases. In other case, you want to make a more sensible choice and using the standard test generator. You're probably familiar with that, but you should know that there is also the plain text gen, that is an alternative way to write test generator that is part of the MPS extension, and basically you can target that with model-to-model transformation. So it's a bit different from the standard test generator. I think it gives you a better idea of how the whole file looks like. I personally never wrap my head around that, but I'm a simple guy using the string builder, but you should look into that because for some problems it makes your life easier. Now, I want to point these articles, but I also want to point out to these blogs because one is from Kolya, the other one is from Sergey. They are both great resources in general for stuff related to MPS. I'm learning a lot reading those. And in particular, they have these resources on generation. By the way, at the end, I will give you a link where you can download the slides. So if you are trying to type in all the URL so far, well, you didn't need to. Maybe I should have said that at the beginning. Now, one particular kind of stuff that you want to generate is documentation. Now, I've copied a piece of an article that Marcus wrote about writing a medical application using MPS. Among the other things done in that project, there was a lot of generating of documentation. In general, generating documentation is a great way to ensure that your documentation is aligned with your code. So that is a point to consider. And you can generate all sorts of stuff. You can generate a testable file, but you can also generate tables summarizing results. For example, the result of the running test, the number of tests, the number of failure. You can generate reports showing the test coverage. You can generate reports showing the number of algorithms, so you could have complexity for metrics and show diagrams of how complexity evolve over time. We have generated all that stuff. And this may be something, this documentation, that you need to generate to give it to people that have not access to MPS, maybe because they're external partners, they don't want to use MPS and read the information from MPS, or because you need to provide this information from a regulatory agency like the FDA. So these are reasons to generate documentation. When you generate documentation, there are at least 3 kinds of tools you may want to use. The first one is the embedded documentation language. The second one is PlantUML, with or without the Plant MPS plugin. And the third one is Graphics. Now, the embedded doc or documentation language, I never understood how it's called, is a language that will deserve its own presentation, but basically you can use it to write text, to add links to some images. You can embed piece of models that will be rendered. And in the end, you can generate PDFs out of it. So it's a great way to write documents directly inside MPS, and very rich documents. So take a look at that. Now, there are graphics and PlantUML that you can use it either to generate documentation outside, or you can use it directly inside MPS. And so we are jumping to the topic integrating tools inside MPS. Tom has already discussed this topic, so I'll not spend much time on it, but basically I created this example in 20 minutes, a very simple process language, and then I want to show a diagram that is generated based on the content of the process, and I can click on the different elements. This is relatively easy to do that in MPS. And as Marcus also said, typically users start a project asking you to create some graphical language. In practice, in the end, it's very practical to have a textual language that is more productive, maybe with tables, and then generate some read-only visualization. And Tom showed how you can also listen to the original model and update the picture. So this is a nice idea, and I will steal that. This is another example built using Plant MPS. So a plugin that I think is part of MPS extension, and it took me literally 5 minutes. So I want to communicate that these integrations are relatively easy because you don't have to rewrite Plant UML. There is already the integration in the project Plant MPS. So they are ready to use, and you create a nice visualization in MPS and enrich what you can do in MPS. Now, there is this other project that I read about, is Fasten, Formal Specification Environment. I think Daniel Razio has played a big role on it. So Daniel Razio is, of course, another key member of our community, and I'm also personally very grateful to him because he and people at Itemis has really helped me when I was learning MPS for the first time in 2012, I think. And among other amazing things that he has built this project, and I think the interesting thing here is that they integrate with this tool, a model checker tool, to perform complex analysis on tools. And this is, I think, a very nice example of how you can use tool to complement the capabilities of MPS and build something that overall provide much more value. So I think it's a nice way, and it's a nice idea to take a look at this project. Now, following a suggestion from Marcus, I just added this slide about the integration with build servers. Of course, one external tools that need to use the capabilities of MPS is a build server. Now, the problem with building integration with build servers is that you need to build to write build module, which is complex. There are great videos from Colia on this topic, so I suggest to look for them because they're really helpful to dive into the complexity of this topic. But then you should be aware of this project. The first one is a project that has been around for a long time, built by Itemis, big surprise, and is called MPS Gradle Plugins. It contains a variety of tasks that you can use to basically integrate the build module. The build module generates a task. You typically want to call it from something more modern, like Gradle, and so this project can help you. There is another project from Sergey that is also called MPS Gradle Plugin. I admit that it seems a bit confusing to me, but is used instead to package and publish MPS languages as Maven packages. So that's also very useful. Same name, but it does something different. And then again, from the embedder project, we have this project embedder build Docker. Basically, it gives you a Docker image that you can use in TeamCity to run MPS headless and run your builds inside TeamCity, another project product from JetBrains. Finally, we have the fourth kind of interoperability. That is, I would say, more recent, and these are external tools that talk with MPS to do something valuable. So they try to take advantage of the great feature of MPS to do something outside of MPS. One project is this project that we have created as Strumenta that is called MPS Server. The basic idea is to make all the MPS API available from outside MPS so that you can have MPS server running, for example, headless on a server. You can call it through HTTP or WebSockets and ask it to read the models, to change a model, get information on concept or languages, calculate the type of something, trigger an intention, all sort of stuff. Basically, sort of remote access to the MPS API. And this is open source. This is just a subset of the route you can call. For example, you can call /languages, and guess what? It gives you the list of languages that are available in the MPS on which MPS server has been installed, because MPS server is basically a plugin for MPS. Now, MPS server is something that you may want to use if you want to reuse the runtime capabilities of MPS. There are situations in which you just want to reuse the models that you've created in MPS outside of MPS. So MPS shut down, you just want to read these models. There are a couple of projects you can use. The first one is called MPS Analyzer from Mainte Borsma. And this project can be used to read models outside of MPS. I think the project is written in Kotlin. You can perform simple fixes for some typical problems that you have with MPS models, and you can access them from Kotlin code. So that is an interesting possibility. At Strumenta, we have built something similar because we have slightly different needs. And there is this other open source project called MPS Interop that can read MPS models, but can also read MPS model in binary format. When you create models, unless you create your own custom persistence, models are saved in this proprietary XML format created by JetBrains, right? However, they shipped with MPS some standard libraries that are stored in another format, the binary format, which is more efficient. The problem is that when you create a language that depends on this standard library, for example, because you're using iname concept, you may need to read those library in binary formats. And this is why we created MPS Interop. For example, we have this use case in which we have created a simple class in a Java class inside MPS, and we want to generate a corresponding TypeScript class. And we didn't want to have the generation run inside MPS. We want to have this generation running from TypeScript because we had libraries in TypeScript to generate TypeScript code was easier. So we wanted this. Now, the problem is if you try to read directly the MPS file that stored this model and you look at the piece that correspond to this field declaration, you can notice, first of all, that is a line 21,000. So you can imagine how complex are those files. And basically, you cannot understand anything because it's all use all sort of indexes, use some compression format. It's complex to use it. So MPS Interop will read that file, will read all the files that are dependent, that are referring to that, find the definition of concept, and give you a JSON where you can understand the information. And so, for example, we can understand that this field declaration is of string type, is visible, and the name is container name. So from TypeScript, we read this exported JSON, and we do our thing. This is something also we generated using this approach. Now, another way to integrate with MPS from outside is to use WebEdit-Kit. I will not talk much about this today because I have another presentation 2 days from now about WebEdit-Kit. But WebEdit-Kit is basically a TypeScript framework that you can use to create editors that talk with MPS server, and so get the information you have in MPS. And the basic idea is that when you open the editor, it calls MPS server and get the information on the model and use it to draw something on the screen. And when you do something like typing or changing a reference, it calls back MPS server and tell MPS server to change the model. So conceptually, it's not very difficult. Now, there is this other amazing project. We are going to have a presentation about this. Sasha Lisson is going to give this presentation. This is built from a previous project they created at Themis, put a lot of work on this, and this is simply amazing, open source, available right now. I've also contributed recently at this project, and I still understand just a tiny bit of all the amazing feature that ModelX has. The main feature I understand is this. It permits basically to save your models on a server or a cluster or server and fancy configuration with Kubernetes, things that I don't understand. And you can basically access this model from your MPS, and if you have 2, 3, 4 people edit the same models, they will see the change of each other. So that's basically magic inside a model server. There is also one other part that I never use, but it's also amazing, that basically permits to see, if I understand correctly, the same editor you see in MPS inside the browser. And it has almost all the features you have in MPS, but in the browser. So it looks amazing. So attend the presentation of tomorrow. Now, a quick recap. We've seen that there are many different ways to complement MPS. We've seen that we can import stuff. We can have one-time import or continuous import. We can import stuff in binary format, textual format, common formats. We can generate stuff. We can trigger the generation in different ways. We can use different transformation. We have different kinds to perform text generation. We have different ways to generate documentation. We can integrate tools like model checkers or graphics or PlantUML to have graphical representation. These are some examples, but you can apply the same mechanisms to integrate other valuable stuff into MPS. And finally, we have this more recent series of tools to take advantage of the capabilities of MPS from outside MPS and enrich the ecosystem. So we have seen that basically there are many different ways to complement MPS to make an ecosystem around the creation and usage of knowledge. So we can integrate existing tools and to create more complex processes and have a richer ecosystem. We can use the generation of documentation, for example, to facilitate discussion, both for internal communication and for training of new personnel. We can improve R&D by importing existing knowledge or by integrating like tools like model checkers, for example. So you can create a richer ecosystem and improve the way you build and use knowledge. And basically, you can leverage the existing knowledge you have outside, you can leverage the existing tools that you have outside MPS and complement what you have in MPS, and vice versa, you can leverage all the value you put in MPS by reusing its capabilities from other stuff that run outside MPS. And incidentally, this also reduces the lock-in fear because it shows you that MPS can be one component in a much larger ecosystem, a vital and core component, but one component in something larger. Some consideration, I think that on many different aspects, we have seen that there is amazing progress. There are great ways to generate stuff. But I think that integration with external tools can grow a little bit, and I think that a project like Modelis and MPS Server can really help us go in that direction. Another thing that I want to stress is this. Of course, as a community, for many years, the community has been basically been Itemis and people like Daniel Razio at Fortis and then at Siemens that have built this initial critical mass. But it was very nice to study what exists to create this presentation and see that there are contributions from a lot of people. I wrote some of the name of the people that wrote article, create tools, create languages, and wrote them on the slides, and I'm sorry for the one that I forgot. But it shows you that we have a community and this is growing. And hopefully also the participation to this event will confirm that this community is growing. So please be an active part of this community and contribute. Finally, there are some resources that you may want to consider. MPS Rocks from Colia, amazing list of interesting stuff created with MPS. There is the Slack channel of MPS. And there is the Strumenta community we have started that is we talk about in general language engineering, but many of the participants are very interested in MPS, so we often discuss also MPS stuff. And well, that's it. You can find the slide with all the links to the amazing stuff people have created. So thank you.
All right. Thank you very much, Federico. As I mentioned before, I really like this talk because it emphasizes how MPS can play well with other tools, and because it also highlights how different people in the community have contributed various utilities and things. So that's a very, very nice message. I have a couple of questions from the chat. One is from Julian. I'm glad Federico referred to the custom persistence for data input. I want to know how to do this. So we only have 13 minutes left, so probably not time for a tutorial, but maybe you have a link or something that you can point people to, a documentation of custom persistence or something?
I think there was a link, and again, you can access the slides, so you will find it. There is a cookbook as part of the documentation. Now it's okay, it's stuck, but anyway, there is somewhere eventually the slide will move. But in general, yeah, here it is.
Right.
In general, it's not trivial. So if depends on how familiar you are with MPS, but basically it means creating reactive to things you can expect, like writing a piece of code that is called when you try to save your model and when you try to load your model. So you will need to create programmatically nodes using the S-Model API. And I've used it for some prototypes, and I remember it was definitely not trivial, and there are not many people using it. So I think this part of the documentation is fairly good, but it's true that it's difficult to find examples. So that could be challenging. Luckily, we have the Slack channel from the MPS community, so probably you will need to ask for help there.
And Bernd also just pasted in the YouTube chat that there is XML persistence sample in the MPS samples, which contains working code. So that's also something to look at maybe.
Yes, and just to clarify about that example, MPS by default is very own complex XML format. But as an example, they've also created another persistent that also use MPS XML, and so that could be confusing, but produce an XML that is very simple and linear and readable.
Yeah. Okay. So what do we have? More questions. Jack is asking, why is generating documentation not a lot used? It's a rather philosophical question, it sounds to me.
Well, I think I should ask it to someone else because I use it. But maybe sometimes I think it's not obvious to think about the things you can do with MPS. So today I wanted to talk to all the other things that you can do besides creating languages and using them, right? And sometimes, if you have not seen those being used in other project, it doesn't come to mind that you could do something like this. And the embedder doc language, I hope it's the right name, it proves that there is some need for that, and maybe we can look for usages of that one to see project that use documentation.
I think there are two different cases, right? One is where you have actually manually authored documentation. You can do that outside of MPS or inside of MPS. If you did inside MPS with the doc language, it is easier to embed nodes and refer to stuff and kind of build almost like literate programming style living documents or executable documents. That's one thing. But the other kind of documentation generation is where you do not explicitly author the documentation, but where you generate from the model some more readable or printable or PDFable representation of the model, visualizations, diagrams, things like that. And these are usually done by people who are forced to do it, like in the healthcare example or in the space domain where Andreas Wortmann of OHB basically generated all the sequence and class diagrams that he's forced to submit to ESA when they are trying to get some of their satellite software certificated. Nobody's probably ever going to look at them, but they count pages, right? So you have to generate all this crap. And so that's the other kind. And that is something that people usually only do if they're forced to.
Yeah, and probably, and this is part of the larger problem that we often discuss, this is maybe the boring bit that project that I mean is not discussed outside the usage of a specific client, so people don't know about that. So that's a point. Another things that I was thinking right now is that those projects where we were generating PDFs, I was using a PDF library to generate the PDF. I was realizing maybe that was stupid. I could generate the embedder doc language model with the embedder doc and then generate it from there.
Maybe.
Because it was a pain to generate PDFs with this library. So I wish I considered that before.
So if even you don't know that something exists in the platform, man. So another comment by Paul, not a question here, but just something he wants to say. Please pass on my thanks. Federico's blog got me through my software construction class in my master's degree. So that's nice.
I'm happy to read about that, or to hear about that.
Yeah, and then Paul is also asking a question: is the process DSL, I guess that was your 20-minute example, right? Is that on GitHub?
Is on GitHub. Maybe I didn't make it public yet, but it was something very simple. I can definitely make it public. It was simple, but maybe if it's interesting, why not?
Okay. And we have to correct the reputation of ESA. Mainte just mentioned that his wife works there, and she confirmed she does read the UML diagrams when she finds them. But it has to be UML diagrams and not any other diagrams. I added that. All right. So if there are no more questions, then thanks again, Federico. Obviously,
Thank
as
you.
usual, very interesting. No more questions. All right.